Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in easy manner. In our organic basic series or organic chemistry series, already we have started the lectures and we have seen how the sigma bond and the pi bond is formed, and next we have seen the sp, sp2, sp3, how it is interlinked with the alkane, alkene and alkynes, and we have seen, and the next we have seen very basic how to represent the one organic molecule. In our one organic compound can be represented in the four different manner, that is condensed form, dash line notation and the bond line notation and the wedge form. Clear? And we have seen the basics of the bond length, bond order and the dipole moment. Now in this lecture we are going to start the classification of the organic compound, how the organic compounds has been classified. Then after that, followed by we are going to see the IUPAC, that is a very basic, and this is the names. Actually we should also have the names, right? Like my name is Naveen sir. In the same way, how the organic compounds having the names. Clear? This is a very key basic. Now from the basic to the advanced we are going to see the what organic compounds name. Now let's start our lecture. Now we'll see the how the organic compounds has been classified. Now first classification of organic compounds. Now how the organic compounds has been classified, now we'll see. Now organic compounds has been classified into two types. One is a open chain and the second one is a closed chain. Open chain and the closed chain. Now in this open chain, again it has been classified into two types. Again it has been classified into two types. One is saturated and one is a unsaturated. One is saturated, one is unsaturated. One is saturated, one is unsaturated. Clear? Now this saturated is nothing but, example of the saturated is alkane. Alkane is nothing but carbon and the carbon will have the single bond. Next, unsaturated. Unsaturated, again it has been classified into two types. One is alkene. Alkene is nothing but carbon, one sigma bond and one pi bond is known as the alkene. Clear? Now next one will be the alkyne. What is the meaning of the alkyne? Alkyne means one sigma bond and two double bonds. Clear? Two double bonds. Here the one bond, one sigma, one pi. Here one sigma and two pi is known as the alkyne. Done. Next comes to the closed chain. Again this closed chain, again it has been classified into two types. Again it has been classified into two types. One is a homocyclic. Homocyclic. Done. And the next one will be the heterocyclic. Heterocyclic. One is a homocyclic, one is a heterocyclic. Now we'll see what is a homocyclic and what is a heterocyclic. Closed chain classified into two types, right? One is homocyclic, another one is a heterocyclic. One is a homocyclic, one is a heterocyclic. Homocyclic is nothing but ring have all same type of atoms. Ring have all same type of the atoms is known as a homocyclic. Again this homocyclic, again it has been classified into two types. Again it has been classified into two types. One is alicyclic. One is a alicyclic. Alicyclic example, cyclopropane or cyclobutane, cyclohexane, cyclopentane. Next one is a aromatic. Next one is a aromatic. Again this aromatic, again it has been classified into two types. Again it has been classified into two types. One is benzonoid. Benzonoid, well-known example for you is a benzene. Benzene is a well-known example for you. And the next one is a non-benzonoid. Non-benzonoid. Non-benzonoid example. No. This is a non-benzonoid example. Clear? Now, what is the meaning of heterocyclic? What is the meaning of heterocyclic? Heterocyclic is nothing but ring contains one or more heteroatom. Heteroatom means nothing but other than carbon. Example, nitrogen, oxygen, sulfur, boron, etc. These are the some heteroatom. Example, this is a pyrrole. You see, this is a carbon, this is a carbon. Now this is a carbon and this is a carbon and this is a ring. But one heteroatom it is present, right? Nitrogen. Clear? Now this compound we call it as a pyrrole. This we call it as a pyrrole. Done? Now this is a classification of the which one? Organic compounds. In this classification of the organic compounds, now next we are seeing aliphatic or open chain. These basics are very important and this terminologies will play a very crucial role while we are solving the questions. Clear? Now here what is the meaning of the aliphatic or open chain? Those compounds in which first and last carbon atoms are not connected. What is the meaning of the aliphatic or the open chain? Now here let's suppose I will take the 3 carbons with or 5 carbons with the which one? Single bond connected compounds or double bond connected compounds or branched compounds. Clear? This is aliphatic open chain. See here, first carbon, this is the second carbon, third carbon, fourth carbon and the fifth carbon. First carbon and the last carbon is not connected with each other, right? That type of the compounds we call it as a open chain. Clear? Next we are having branched or unbranched chains are possible. Branched or unbranched chains are possible. Clear? Now what are the unbranched and branched? Unbranched means straight chain. This is unbranched. Clear? Now what is the meaning of the branched? Branched means here carbon and another carbon. Now here the carbon, here the carbon, here the carbon, here the carbon. Clear? Now this is a branched. Clear? In this next we are going to see again the open chain has been again classified into 2 types, right? Just now we have seen open chain again classified into 2 types, that is saturated and unsaturated. Saturated and unsaturated. Saturated means these compounds attached with carbon single bond carbon, and general formula for this saturated compounds we call it as, the general formula is CnH2n plus 2, and we can call it as a paraffins also. Clear? Now example for the saturated compounds. Example for this one, we call it as a alkanes. This alkanes we can call it as a paraffins also. Paraffins also. Clear? Now these are less reactive. These are less reactive due to absence of pi bond. Due to absence of pi bond. Due to the absence of pi bond, these are less reactive. Next, saturated, it is completed. Now we are going to see the unsaturated now. In this unsaturated, we are having the alkene. Alkene means carbon double bond carbon. Means it is connected with one sigma bond and one pi bond. And the general formula for this one will be the CnH2n. CnH2n. Clear? And the next one we are having the alkyne. Next one we are having the alkyne. For this alkyne, the general, it is connected with one sigma bond and two pi bonds. Two pi bonds. And the general formula will be, what is the general formula for the alkyne? That is CnH2n minus 2. CnH2n minus 2. Clear? Done? Now we will see the how it has been classified. Now what we have seen just now up to now. Now alkenes we have seen, right? Alkenes means one sigma bond, one pi bond, and the general formula will be CnH2n. Next, alkyne. Alkyne, it will be the one sigma bond and two pi bonds, and the general formula will be CnH2n minus 2. CnH2n minus 2. Clear? Now next comes to the closed chain. Next we are having the closed chain, right? Next we are having the closed chain. Now in this closed chain, what closed chains, again we are having the two types of the closed chain, right? Two types of the closed chain. One is homocyclic. One is homocyclic. Homocyclic closed chain. Now what is the meaning of the homocyclic closed chain? These are the compounds in which complete ring is formed by only carbon atoms. Clear? See, complete ring is formed by the, which one? Complete ring is formed by the, complete ring is formed by which one? Carbon atoms only. Clear? Now here this homocyclic, again it has been classified into homocyclic. This homocyclic means complete ring is formed by the carbon atoms. Again it has been classified into two types. What are there? One is alicyclic, one is a aromatic, right? One is alicyclic, one is aromatic. What is the meaning of the alicyclic? These compounds have properties like aliphatic compounds. Clear? These compounds have properties like aliphatic compound. These compounds have properties like aliphatic compounds. It may be this alicyclic, it may be saturated alicyclic or unsaturated. It may be saturated or unsaturated. Examples are, one is cyclopropane. Clear? One will be the, this is which one? Cyclobutane. The same thing, cycloalkene, cyclobutene. Clear? Cyclobutene. Done? Now next one, if you see, this is cyclohexane. Now this one will be the cyclohexene. Clear? Now These are the alicyclic compound. Alicyclic compound. Next comes to the aromatic. Now comes to the aromatic. Now what are the aromatic compounds? Now aromatic compounds. Clear? Now aromatic means these compounds should contain, or this compound should consist at least one benzene ring. One benzene ring. Aromatic compounds means these compounds should consist at least one benzene ring. Example, benzene. Clear? Next one. Another one is a naphthalene. Clear? Next one will be the phenanthracene. Clear? Now, clear? Done? Now, next. Now, next we are having the heterocyclic compounds. Now, what is the meaning of the heterocyclic compound? Now, already said these are cyclic compounds. These are cyclic compounds having ring other than one or more hetero atom in the ring. In the ring is called heterocyclic. Is called heterocyclic. Example, this is which one? Pyrrole. This is pyrrole. Now this is thiophene. Clear? And the next one will be this is furon. Clear? This is a furon. This is a pyridine. This is pyridine. Clear? Now next we are going to see homologous series. Next, what we are going to see? Next we are going to see the homologous series. What is the meaning of the homologous series? Means now this series of organic compounds, in which all the members can be represented. All the numbers can be represented by one general formula. One general formula is homologous series. Clear? Now, homologous series means the compounds, organic compounds, is having the difference of one general formula. Means two consecutive homologous differ by one CH2 unit or 14 AMU, 14 atomic mass unit. Clear? Now example are CH4. If you take, this is a CH4. Clear? Then next one will be the CH3 and the CH3, and the next one will be the CH3 CH2 and the CH3. Clear? Now you see here this is a CH4. Done. Now this one will be the C2H6, right? C2H6. For this CH4, if I add the CH2, this CH4 also will become 2 carbons and 6 hydrogens, right? C2H6. Done. This CH4 and the C2H6 is differ with the one CH2 unit. Again this CH2, this is C3H8. For this C2H6, if I was added the CH2, already 2 carbons are there, that will become 3, C3, and here it is having the 6 and 2, 8, total C3H8. Clear? Now this is known as a homologous series. Done? Clear? And next we are going to see the functional groups. Clear? Now what are the functional groups that we are having in our chemistry? Now we are going to see. What is the meaning of the functional group? This is very, very important. Functional groups. Clear? Functional group. What is the meaning of the functional group? What is the role of this functional group? Which is responsible for chemical reaction. Which is responsible for chemical reaction is known as functional group. Functional group. Done. Now we'll see what are the functional groups we are having in our chemistry. First one, this is name. Name is the first one is a carboxylic acid. First functional group we are having the carboxylic acid. Done. Now functional group. Now what is a carboxylic acid? How the carboxylic acid will be? C double bond OH. C double bond OH. Clear? Done. Now the formula will be CnH2nO2. CnH2nO2. This formula is applicable only for the monocarboxylic acid. Monocarboxylic acids only this formula will be applicable. Done. Now we'll see another one. Second one we are having the sulfonic acid. Done. Now sulfonic acid will be the SO3H. Next one, third one will be having the acidic anhydride. How the acidic anhydride will be? C double bond O bond C double bond O bond. Clear? Now this is the acidic anhydride. Now fourth one we are having the ester. C double bond O bond OR. This R is nothing but alkali. What is the meaning of alkali, sir? In the upcoming classes I will explain very clearly. Alkali is nothing but, this is CH4, right? For this CH4, if I was removed one hydrogen, then it will become CH3. This one we call it as a alkali. For the ethane, if you remove one hydrogen, that will become ethyl. For the methane, if you remove one hydrogen, it will become ethyl. So instead of representing this CH3, this R may be methyl, ethyl, propyl, butyl, anything. Clear? Done? Now here this general formula for this one, CnH2nO2. Next, fifth one, acid halides. Next one will be the acid halides. Now formula will be C double bond O X. Clear? Next, up to where we done? Fifth. Next one we are having the sixth. Now sixth we are having amide. Now amide formula will be C double bond O NH2. Done. Next, seventh we are having the cyanide. Now cyanide will be C and N. Clear? Now next one will be the isocyanide. isocyanate. Next one, ninth one, we are having the aldehyde. Now aldehyde functional group will be the C double bond O H. Next, eighth one, we are having the ketone. Now ketone functional group will be the C double bond C. Clear? Now ninth one, we are having the thio alcohol. Thio alcohol, that is SH. Next, tenth we are having the amine. Amine, it is NH2. Next, 11 we are having the ether, ROR. Clear? Clear? Now these are the, now up to amines. Now next one will be the double bond, C double bond C. Clear? Next one will be the triple bond, C triple bond C. Clear? Next one will be the single bond. Actually these are not the active functional group. Like just now carboxylic acid, aldehyde, ketone, ester, acid halide, acid amide. Clear? Now next we have seen the acetic anhydride. Those are the active functional group, but these are not the active functional group. This double bond, triple bond, ether. Clear? These are not the active functional group. Next another two groups are also there, that is NO2 and halogens. NO2 and halogens will never act as functional group. Clear? Now when we are starting the IUPAC, there we will get to know very clearly. Clear? Now by this I was going to stop the lecture, and the next class we are going to start with the which one? IUPAC. With that IUPAC continuation will start the followed by isomerism and the rest GOC and continuation of the organic series. Clear? Now see you in the next lecture.